All right, we're going to write some linear inequalities in two variables. So before this, we were given an inequality in two variables, like right here. I wanted to make sure we knew what a solution, or to be able to check to see if something was in the solution of that. We also went further, and as a part of the graphing, you should include some shading because it's more than just one item. It's either greater than or equal to. Did a couple of examples of that. Now I want to kind of go the other way, and I wanted to actually, starting with a graph, write the linear inequality that's in two variables. So we're going to do that right now. I'll use this Alex example for an example, so I don't have to actually draw the graph. But in this example, I want to write the inequality for this graph. I know it's an inequality because it's shaded, and I also see that this is a dotted line, so that's a little bit of a dead giveaway also. All right, first thing we need to do is write this thing as if it was the equation of a line. So if it's the equation of a line, I'm going to put it in slope-intercept form. And we're going to change this because it's not actually equal. It's going to be either less than or equal to, less than, greater than or equal to, or greater than. But for right now, let's establish the line. We've done this before. This is in the other unit. So I know I'm going to have a y. I'm going to have an x. I need to find the slope. And if I start here and go to this point, I have to go up 8. So up 8, because you can just count them, 1, 2, 3, 4, 5, 6, 7, 8. And then to the right, 2, 1, 2. So to the right, 2. That gives me my slope. Now my y-intercept is at 5 plus 5. Now I can simplify that, so let me do that. Y is going to equal 8 divided by 2 is 4x plus 5. So far I've established my boundary line. Right? Now I know it's not an equal to because I have shade, but if I look at my line, it is dotted. Dotted lines mean that you do not include the equal part. So I'm still going to have 4x plus 5. I just need to see if I'm going to put one of these in here or one of those. I will not do one of those, or I will not do one of those because it's dotted, and that would imply that I have an equal to. So it's going to be one of these. When I look at my shading, it looks like all of my shading is kind of below my line. So for right now, I'm going to assume that all of my y's are less than all of my stuff. All right, so all of my y's are less than this line. Now I should probably check that just to make sure I thought about it right. So if I choose any point in this shaded area, it's a part of the solution. If I choose a point and plug it into here, and I get a true statement, that means that my statement is indeed true and my inequality is true. I always like to use the point 0, 0. Fortunately, it's in the solution already. It just makes the math easier. So if I test that, then y is 0. I have 4, 0, plus 5. So if I just simplify on the right side, that's a 0 plus 5. And I'm asking myself, is 0 less than 5? The answer is yes. Because this point 0, 0 is in the solution set, and I've already established my boundary line, this is correct. Okay. Now I want to also be able to write linear inequalities in two variables if I'm given some information. So if I look at this one, for example, this is a word problem. It says that Elsa's final exam has true-false questions worth 4 points each and multiple choice questions worth 5 points each. Let X be the number of true-false. Let Y be the number of multiple choice. She needs to get at least 93 points to get an A. I want to write an inequality to prove that. So in this example, we've already established that X will be the true-false. Y will be the number of multiple choice. I know that for every true-false, I get 4 points. Plus, for every multiple choice, I get 5 points. I need that total to be at least 93. So I need this to be greater than, but it could also be equal to 93 because it says at least. If it said more than, I wouldn't include that, but it said at least, which is greater than that or equal to that. That right there would represent an inequality in two variables for this situation. All right. I think that should be enough for you to kind of get the gist of what we're trying to do. So we can work with that.